Hi, grade 9. We're going to revise some of the topic that we studied before because it's an introduction for our lesson today. We're going to revise about the waves. We have two types of the waves. We have a mechanical waves and we have electromagnetic waves. I said before that the mechanical wave, it's a type of the waves that need a medium to travel through. So what's meant by the mechanical wave? It's the waves that need a medium to travel through. While the electromagnetic wave, they travel through the space or through the vacuum. Mechanical wave can be divided into transverse or compressional. What is the difference between the transverse and the compressional? Transverse wave, it's like the shape of the wave. It formed from the crest, which represents the highest point, and the trough, which represents the lowest point for the medium particles. An example for it is the water. I told you before that the transverse wave, the medium particles move perpendicular to the direction of the wave that travel, while the compressional wave or the longitudinal wave, it's a kind of the wave or the mechanical wave that need a medium to travel through, and it's formed from compression and rarefaction. What's meant by compression? It's the medium particles in which high density for the medium particles. All the medium particles here come closer together, so it represents the compression. While this part or this part represent the rarefaction. It's the lowest density for the medium particles. They get farther apart from each other, so it represents the rarefaction. How about the electromagnetic wave? Electromagnetic wave, it's the wave that can travel through the space. And an example for that, our abbreviation RAM-EVUXG. They represents radio wave, microwave, infrared, visible light, ultraviolet, X-ray, and gamma ray. And as you know, all of these are transverse wave. They travel through the space with a very fast speed that represents the light speed, which is 3 times 10 to the power 8. Our lesson today, it's talking about the sound, which is a kind of the compressional wave. Sound wave is a compressional wave. Why? Because it's formed from or travel through the material as compression and rarefaction. Compression represents the highest density, rarefaction represents the lowest density. And whenever you think about how do you make the sound or how the sound is produced? The sound is produced due to the vibration of the medium particles. So what's meant by the vibration? It's a quick rhythmic back and forth movement. What's meant by the vibration? Quick and rhythmic back and forth movement. So anything like the tuning fork can vibrate or make a quick rhythmic back and forth movement, it produces a sound wave. It produces what? A sound wave. So vibration produces the sound wave. We have some properties of the sound wave we're going to study in this lesson. We have 3 properties of the sound wave. We have the sound speed, we have the sound intensity or loudness, we have the sound pitch. What's meant by the sound speed? It's the speed by which the sound wave can travel through the different mediums, and it depends on 2 factors. It depends on the medium itself, and it depends on the temperature of the medium. How do you think it depends on the medium or depends on the temperature? You know that we have 3 types of the medium. We have solid, liquid, gas, and in each part of it or in each kind of it, we have particles. These particles in continuous motion, they have distance between them, which is called the intermolecular spaces and distance between them. So in the solid, the particles are so close to each other. So whenever the sound moves, it transfer energy. Any wave that travel, it transfer what? Energy from one place to place. And in the solid, the medium particles are closer together, so it transfers the energy faster than the liquid, because the medium particles in the liquid has bigger distance than the solid, while in the gas they are very, very, very large spaces between the particles. So it takes a lot of time to transfer the energy between the particles, so the speed of the sound in the gases is very slow. So we have graduation. The speed of the sound in the solid is very fast, while in the liquid it's intermediate, in the gases it's the slowest speed. So the speed of the sound depends on the medium or the material it travels through, and it cannot travel through the empty space or the vacuum because it's a mechanical wave, as we said before. How about the temperature? The temperature affects the sound wave too. As you know before, that the temperature, whenever increasing the temperature, it means the medium particles start to move faster. and they colloid more, so the sound wave can move faster. So increase the temperature, increase the collision between the medium particles, making the molecules move faster and traveling faster, transferring the energy from one place to another faster. So by increase the temperature, it leads to increase the speed of the sound.